I want to talk about inequalities, interval notation, and plus minus notation. Let me just start reminding you about the number line. So here's one of my favorite things in the whole world, the number line. 1, 2, 3, -1, -2, -3. And the thing is, it goes on forever and ever and ever in both directions. And the symbol we use to show that is, it kind of goes to that symbol. It's sort of a sideways 8 is infinity, and on this side it goes forever and ever and ever, and it goes to negative infinity on that side. So if I have an inequality, here's an example. Suppose I say graph and write interval notation for x less than 3. So what part of the number line is where x is less than 3? So let me just, so it's x is less than 3. Here's the number line, 0, 1, 2, 3, -1, -2, goes forever and ever and ever. So x is less than 3 is going to be all the numbers below 3 there. So I'm going to draw an round bracket at 3 and sort of cover in the number line all the way, and it goes all the way forever and ever and ever on that side. And if I wanted to write this in interval notation, because it goes forever and ever and ever towards negative infinity, we kind of start the interval with a round bracket, negative infinity, and then it goes all the way up to 3, and again a round bracket. The round bracket means that the endpoint is not included in the interval, and the little compare and contrast essay for that would be this example. Graph and write interval notation for x greater than or equal to 2. Notice the little or equal to. That's going to make a difference in what kind of bracket I write. So we're doing x greater than or equal to 2. So this time, here's the number line. 0, 1, 2, -1, -2, 3, 4. So this time x is greater than or equal to 2. So we want all the numbers higher than 2. And because of the or equal, we want to include 2 in the answer. And so the way we notate that is using a square bracket. That square bracket means 2 is included, and the portion of the number line starts at 2, including 2, goes all the way up to positive infinity. In the interval notation, we start at 2, and we're using a square bracket to indicate that 2 is included, and this is going up to positive infinity. Infinities always get a round bracket, so the square bracket, just to reiterate, square bracket means 2 is included, and it's because of the symbol greater than or equal led to using the square bracket. Okay, now we can do the same thing where x is kind of trapped in between two numbers on an interval. Here's another example. Graph and write interval notation for this inequality, 4 less than x less than 6. So notice even the way it's written, this is kind of saying x is trapped between 4 and 6 is a way of thinking about this. X is trapped between 4 and 6. So on the number line, Here's 0, 1, 2, 3, 4, 5, 6, 7, etc., etc., etc. Now notice it doesn't say less than or equal, it's just strictly less than. Strictly less than, so that means I'm going to put in round brackets. And the numbers that we want are just between 4 and 6. So it starts at 4, it ends at 6, and I'm sort of shading in that part of the number line. And the round bracket, because 4 is not included. So it's just that part of the number line. If I wanted to write that as an interval, it looks like this. It starts at 4 and it ends at 6. And the round brackets are because it's not less than or equal, just less than. Round bracket goes with just the less than symbol. Now, of course, the compare and contrast essay would be an example such as this one. So here's another example. Suppose graph and write interval for 2 less than or equal to x less than or equal to 8. Notice this one has less than or equal, so that means I'm going to use square brackets to indicate that the 2 and the 8 are included. So on the number line, say put 0 there, 1, 2, 3, 4, 5, 6, 7, 8, 9. It goes on forever, of course. So now x is trapped between 2 and 8, square bracket at 2, square bracket at 8, and it's everything in between there. That's the solution for 2 less than or equal to 8. And the corresponding interval would be square bracket 2, square bracket 8, square bracket goes with the less than or equal symbol. Okay, now, sometimes, especially in statistics, they will write intervals in what's called plus-minus notation. And so another kind of example they give in the homework is this kind of a question. Here's an example. Convert the interval between negative 1.6 to 2.4 to what's called plus-minus notation, and determine if 0 is inside the interval. Okay, well, first of all, because the lower number is negative and the higher number is positive, 0 is going to be in between. So if the lower edge of the interval edge is negative, the higher edge is positive, that means 0 is included in the interval. Okay, so that question can be dispensed with pretty much immediately. Yes, 0 is inside the interval. Now to write it in plus-minus notation, there's a couple of algebra steps that I need to do. So to convert negative 1.6 to 2.4 to what's called plus-minus. Step 1, first I'm going to find the midpoint of this interval by adding these two numbers together and dividing by 2. Find the midpoint, which would be negative 1.6 plus 2.4 divided by 2. Now on the calculator, of course, when I'm doing a fraction, I'm going to put a parentheses around the numerator. Parentheses, that's a negative number, not a subtraction sign, so I'm doing negative 1.6 plus 2.4, close the parentheses, divided by 2, and that gives me 0.4. So that's the midpoint of that interval. And then the second step is find the distance from the midpoint to the right edge by subtracting right edge minus the midpoint. So in this example, the right edge was 2.4. The midpoint was 0.4. So the right edge minus the midpoint, 2.4 minus 4, 2.4 minus 0.4 is 2. Okay, so once you get that first step and the second step, the answer to the plus minus notation, it's the midpoint plus or minus the distance. So the answer is 0.4 plus or minus 2, and that 0.4 was the answer to step 1, which was the midpoint. And this 2 came from the answer to step 2. Answer to step 2, which was the distance from right edge to midpoint. And that's what's called the plus minus notation. There's one more kind of example in this homework, and that's going the other way. So here's the last example for this homework. Is going the other way. Convert 3.1 plus or minus 1.7 to an interval, and determine if 0 is contained in the interval. Well, in the previous example where they gave us the interval and the lower number was negative and the higher number was positive, we could tell right away that 0 was contained. Now we're going to get the interval, and from there we'll figure out if 0 is contained. So to find the interval, the left edge is 3.1 minus 1.7. 3.1 minus 1.7. 3.1 minus 1.7. That's 1.4. And the right edge is 3.1 plus 1.7. 3.1 plus 1.7. That's 4.8. And so the interval is 1.4 to 4.8. Because both of these numbers are positive, 0 is not contained in the interval. Both positive, 0 not in the interval.